All right, here's a video that goes along with the second portion of today's learning. Very simple idea. You're given a terminal side of an angle, right? So boop, 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 boop. There's your terminal side of your angle. And they say it's -9, back 9, and up 12. The y value, that's going to help us with our sine. And this is going to help us with our cosine. But really and truly now we're going to have a hypotenuse that we have to worry about. Okay? And so what do? We use the Pythagorean theorem to find our hypotenuse. And I showed you that, and I showed you how to do it with this one. I'm going to show you again with this first one, because I don't want to have to do your homework for you. I'd rather you did some homework. So we go ahead and we draw this. We put together, here we go. Craziness. We put together a coordinate plane. I don't know why that happens. Anyway, over 2, down 5. I'm just going to make it look like that. And we can say that it continues there, but this is where it terminates for our purposes, right? That's our angle that we're going to use. In reality, our angle is this, right? That's theta. But we're going to use this. That's going to help us. Our y, our x, right? And so there's our right triangle. It's 2, it's -5, and then we're going to find this. So we say that the hypotenuse is equal to the square root of 2 squared plus -5 squared, which is the square root of 29. Now, if you couldn't find that out on your own, I'm really sorry, but I don't have time to go over how to use the Pythagorean theorem. If you don't know that, then you shouldn't be in an honors class, and I apologize for being mean. Anyway, here we go. I'm going to write down the sine and the cosecant of that same value. I guess I'll drop it down because that's in my way. So I'll say sine, cosecant. Got to move it over because I have to simplify. I'm going to say cosine. I'm going to say secant. And tan. Cotan. These are the easy ones, right? We already had these values, didn't we? -5 over 2, right? Opposite over adjacent. Well, if that's -5 over 2, then this is 2 over -5. Same idea. There we go. So let's go back up here. -5 over the hypotenuse of root 29. This is actually -5 root 29 over 29, because we don't like to have a square root in our denominator. But I'm going to write it like this, so I can say root 29 over -5. Sounds good. Cosine is 2 over root 29. Again, 2 root 29 over 29 is our real answer. But when I get back to here, I want to have this as root 29 over 2, because it makes life so much easier, right? So these are our real answers when we end up with the square root. Will I be upset if I see that? Maybe. What I'll really be upset with is our decimal answers. You need to leave them as fractions because they're comparisons of sides. Down here at the bottom, there are a couple ways to go ahead and solve these. I don't need that. Get out of here. Here we go. If I want to find the sine of 5 pi over 3, it's really pretty easy, especially since I already had you draw the unit circle, and 5 pi over 3 is down here, right? It's 60 degrees away from 180. And so we have what, -1/2, and negative root 3 over 2 as our sine, cosine, that, right? So you could plug this in, negative root 3 divided by 2, and then hit enter. Remember to put a space here or else it'll just put the division symbol and they'll do all the division underneath the square root symbol. So you should space it out. Not a big deal. Or you could just hit sine 5 pi over 3. Make sure you're in radian mode if you're going to use radians, and degree mode if you're going to use degrees. So you can use your calculator for it. I don't mind. It's pretty simple, though. Right? But, again, why do we want to find the square root of 2? Right? Or 1 over the square root of 2. Yeah. Right? We hate that crap. So this is negative square root of 2. It's better if you type it in degree mode. 1 over the sine of 210. Okay. Sound good? That's that part. And last but certainly not least, the true reason I had you create the unit circle was so you could find these values. Here you go. Now you know what these values are and where they lie, right? You can go ahead and say right now, hey, doesn't exist. Sokol already showed me it doesn't exist. If this were the tangent of 270, we'd say, hey, Sokol already told me that doesn't exist. But it does exist because it's the cotangent. Flip it over. If we have, are there any cheaters? No. Can't cheat on any of them. Type them into your calculator. It says find the exact value. When I give you a test like this, I'm going to want the value that's on the unit circle, right? Your actual test is going to be filling in the unit circle. And then you're going to have a couple of these to fill in, okay? So that's how you do it. Sorry it's so long. I know it's only 7 minutes, but it's kind of long. There you go.